So what is anything is left? Huh? Normalization, huh? Okay. So see what is normalization is, see what I said, it's not related to database development, it is related to design, database design, designing the tables. So and normalization is the process of decomposing tables with redundancy into number of well structured tables. You know, it is the process of decomposing tables with redundancy into number of well structured tables. Decomposing means what? Dividing. Dividing the table into number of well structured tables. That process is called what? Normalization. Dividing a single table into multiple tables. But which tables are divided? Which tables are divided? Tables with what? Redundancy. Table with redundancy. Redundancy means duplication of data, repetition of data. So those tables are divided into number of tables. Okay, then I'll take example. Suppose, like, see this. I want to design a table for like one. Suppose store is there or supermarket is there. I want to design a table for that supermarket. So customers go to the store, customer purchases items, a bill is given to the customer. Customer go to the store, purchase items, a bill is given to the customer. So I want to store this data. I design a table. What the table is? Bill table. Bill number, bill date, customer code, customer name, customer address, and customer purchases what? Items, item code, item name, item rate, item quantity, item value, total bill. So I design a table like this. Customer go to store, purchase items, a bill is given to the customer. So that is a bill table. Bill number, bill date, customer code, name, address, item code, name, rate, quantity, value, total bill. Okay, understood? Then, but here, see, suppose then, suppose a customer is purchased like 20 items. A customer purchased what? 20 items. Item code is 1, item code is 2, item code is 3. Like that, customer purchased what? 20 items. Okay. But for all 20 items, bill number is what? For all the 20 items, bill number is same. Same bill, different bill. You give the same bill, even if customer purchases 100 items, so bill number is what? Same. Bill number is same. Bill date is same. Customer code is same. Name is same. Address is same. For all these 20 items, this data is what? Repeated. So for all the 20 items, these values are repeated. So what this is called? Redundancy, duplication of data. Okay, then. So if table contains redundancy, what the problem is? Memory wastage. What the problem? If table contains redundancy, problem is memory wastage. But memory wastage plus in this table, insertion is a problem, updation is a problem, deletion is a problem. Inserting is a problem, updation is a problem, deletion is a problem. Suppose I want to change the customer address. So how many times address is repeated? 20 times. That means if you want to update the address, how many rows you have to update? 20 rows. Because this address is there 20 times, you have to update 20 rows. Updation is a problem or not? Yes. And you cannot insert what's the customer data without bill number, because bill number is primary key. Without bill number, you cannot insert what customer data. You cannot insert the customer data without bill number. Yes, insertion is a problem. Deletion is a problem. Updation is a problem. So all these operations are what? Problem. So then what? So reduce what's the redundancy. To reduce the redundancy, apply normalization process on this table. Okay, na? So the above table contains what? Redundancy. Then, and that leads to what? The redundancy leads to problems. What problems? Insertion, updation, deletion problems. So to overcome these problems, apply what? Normalization process. Okay. Then, so the above table contains uh, the above table. So the above table contains what? Redundancy. Okay. Then, and that leads to insert, update, delete what's are anomalies. Anomalies means errors, problems. Anomalies means what? Insertion is an error, updation is an error, deletion an error. Errors means problems. Like, so the above table contains redundancy that leads to insert, update anomalies. Next, to reduce redundancy, apply a what? Normalization process. Okay. Then next, now, and like, and normalization process is what? Set of rules, and each rule is called normal form. Normalization process is set of rules, and each rule is called one normal form. Normalization process is set of rules. Each rule is called one normal form. There are six normal forms, and there are six normal forms. Set of rules, and each rule is called one normal form. There are six normal forms: 1NF, 2NF, 3NF, BCNF, 4NF, 5NF. So this process is set of rules. Each rule is called one normal form. The first normal form, second normal form, third normal form, BCNF, 4NF, and 5NF. Okay. So what is BCNF stands for? Bias caught normal form. BCNF stands for bias caught normal form. Okay. Then next. So the first three are called basic normal forms. BCNF, 4NF, 5NF are called advanced normal forms. The first one, two, three are called basic normal forms. BCNF, 4NF, 5NF are called advanced normal forms. Okay. Then so now, but actually you never come across applying BCNF, 4NF, and 5NF. Rarely you come across applying this BCNF, 4NF, but most common is what? 1, 2, 3. So you should know 1, 2, 3. When interviews also they'll ask this 1, 2, 3, but they don't ask this one BCNF, 4NF, and 5NF. So this is just for interview purpose. That's all. Okay, na? Then after getting through the interview, you don't use normalization in real time. Okay. Then okay. Then we'll see one by one. So what the first normal form? Sir, each normal form is a rule. Each normal form is a rule, and you apply these rules on what? You apply these rules on tables. You apply these rules on tables. What the first normal form? Okay. Then a table said to be in first normal form. A table said to be in first normal form if there are no multi-valued attributes in it. Multi-valued attributes in it, or all the attributes in table are what? Atomic. Atomic means what? Single. A table said to be in first normal form if there are no multi-valued attributes in it. If there are no multi-valued attributes in it, or all the attributes in table are what? Atomic. Atomic means single. Okay. Then so table should not contain multi-valued. Table should contain only single value. So all the attributes must be atomic. Let's apply this rule. Let's apply this rule on this table because we are taking this example now. So we apply this rule on this table. Then now let's see. Okay. So each bill has how many bill numbers? One bill. You take one bill that has how many bill numbers? One bill number. Single. Billets one. How many customers? One customer. Name one. Address one. One bill. Customer purchases how many items? Many. Item codes? Many. Multi. Names? Item name? Many. Item rate? Many. Quantity? Item quantity? Many. Value? Many. Item value? Item value. Next one. Total bill? Total bill? One. Single value. One bill has total bills how many? One. This is individual item values. Individual item value. But this is total bill. That. So this is single. That means in this table, some of the fields are what? Some fields are single, some fields are multi. So this table is not according to first normal form because For the first normal form, all the attributes in table must be atomic. But here, some attributes are multi. So this table is not according to first normal form. If the table is not according to first normal form, then what? Divide the table, decompose the table. If the table is not according to normal form, then what? Divide, decompose the table. Decompose the table into how many tables? Two tables. In one table, take all single valued. In one table, take all multi valued. So then, sir, in the above table, some fields are single and some fields are multi valued. So table is not according to first normal form. In the above table, some fields are single and some fields are multi valued. Okay, then multi valued. So table is not according to first normal form. Then 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 decompose the table as follows. Decompose means divide. Divide the table. Okay, then so table is not according to first. Then decompose the table as follows. See, listen. So then in one table, I'm taking single value, bill number, bill date, customer code, customer name, customer address, and what? Total bill. So all these attributes are single. So take single valued into one table, multi valued into another table. What that is? Just listen first. What? I'll take items, item code, item name, item rate, item quantity. Next one, value. So listen first. So you divided the table into what? Two tables. In one table you taken single. In another table taken what's it? Multi. Yes or no? Then. So but after dividing the table into two tables, what is missing here? You divided the table into two tables. After dividing the table into two tables, what is missing here? Relationship is missing. Like here, I'll ask, sir, this item belongs to which bill? Can you answer? Now here in this table, if I ask item 1 belongs to which bill? 1000, bill 1000. Item 2 belongs to which bill? 1000. 3 belongs to 1000. After dividing the table into two tables, item 1 is there, item 2 is there, item 3 is there. I'll ask these items belongs to which bill? Can you answer? No. That means after dividing the table into two tables, what is missing? Relationship is missing. Then introduce establish the relationship. To establish the relationship, what? To establish the relationship between two tables, then add foreign key. Add what? Foreign key. Adding foreign key means take primary key of one table, add that primary key to another table. So to which table you add foreign key? Bill table or items table? Sir, what is the relationship here? Between these two tables, what the relationship is? One to many. What is the relationship? One to many. One bill, many items. One bill, many items. Relationship is one to many. If the relationship is one to many, add foreign key to what? Many side table. You know that relationship is one to one. You can add foreign key to any table. Relationship is one to many. Add foreign key to many side table. Okay. Now here the relationship is one to many. Add foreign key to many side table. So what is the foreign key? Add foreign key to items table. What is the foreign key in items table? Bill number. Yes or no? Take primary key of bill table. Add this primary key to items table. In bill table, bill number is primary key. In items table, bill number is foreign key. Why you added? To establish what? Relationship. Suppose bill number is 1000. This is 1001 something. So items table. Bill number is 1000. Customer is purchased item 1. In same bill, customer is purchased item 2. This is another bill, means different customer. He also purchased item 1. This is another bill. Customer purchased item 2. In one bill, customer purchased item 1 and 2. Another bill also customer purchased item 1 and 2. Possible or not? Different customers can purchase same items or not? Yes. Okay. Then, so this is the table. So this is one table, bill table. This is another table. Let's name this table as bill items. Okay. So in this table, what is primary key? Bill number. But in bill items table, what is the primary key? In bill items table, what is the primary key? Huh? Can we take bill number as primary key? No. Bill number is what? Repeated. Can we take item code as primary key? No. Item code is also repeated. Yes. Then what? Take name. How can you take name, boss? If not possible with these two, then name. Then how can you take name? Your name is what? Your name is some name. Here also item one name is same now. Then when item code is repeated, item name is also repeated. Then how can you take item name as primary key? Huh? What is another column? There is no other column. Then only these columns. Then when not possible with bill number, not possible with item code, not possible with single column, take combination. Take what? Combination. That is called composite primary key. When not possible with single column, then take combination of this column. So can I take this combination? Can I take this combination? Bill number plus item code 1001. How many rows selected? 1. 1002. 1. 1001. 1. 1. 1001. 2. 1. So this combination is selecting how many rows? Only one row. So this combination can be taken as primary key. Yes. Sir, understood? Now, see, decompose the table as follows. And after decomposing, after dividing the table into two tables, establish the relationship by adding foreign key and identify primary keys. Sir, understood or not? Then, okay. Then, so this is the actual first normal form. So in this table is not according to first normal form. Then decompose the table and establish relationship by adding the foreign key and identify the primary key. That's all. So this is after first normal form.
ఎంతసేపు పోస్తున్నావు మబ్బు మూసుకుందా వాన వచ్చేదాన్ని నిద్ర వస్తుంది నువ్వన్నా మధ్యాహ్నం నిద్రపోయినవులే మధ్యాహ్నం నిద్రపోతున్నా కొంచెం ఇప్పుడు నేను పడుకున్నావు కదా కళ్ళు మూసుకొని తీసుకోవడం తర్వాత అంటే రేపు బుక్ చేసుకొని ఇంక మళ్ళీ ఈ రోజు అంటే ఆడ వెంటనే పోవాలంటే పోలేం కదా రేపే పోవాలంటే ఎల్లుండి బుక్ చేసుకుని ఏడుండి వేస్తే నీరు పెద్దగా వేస్తుంది అదే ఆడుండి టయార్లో వేసినామంటే ఫంక్షన్ బిర్యానీ అంట నేను చేసుకున్నది ఈరోజు చేసుకున్నది అప్పుడు తీసుకోవాల్సిన మెటీరియల్ ఇంకా అక్కడ తేవాలి కొట్టలేదు అంట అంత అడిగినట్టు ఎప్పుడు జడ జడ 5 అయిపోతుంది. ఇచ్చేసిన సీట్ డబ్బులు. బైక్ ఇంక వినోదం అది తీసుకుంటాను. ఇంకా
Okay.
ఉందలే.
No. Okay then. Sir, after dividing the table into two tables, is redundancy is reduced or not? Yes. How redundancy is reduced? Earlier, for if customer purchases 20 items, for all the 20 items, what is repeated? Bill number, date, code, name, address is repeated. Now, after dividing the table into two tables, if customer purchases 20 items, for the 20 items, what is repeated? Only bill number is repeated. But date, code, name, address is not repeated. Only bill number is repeated. Yes or no? That means redundancy is reduced or not? Yes. Redundancy can be reduced, but redundancy cannot be completely eliminated. You can reduce, but you cannot completely eliminate. To completely eliminate the redundancy, then don't take what? Bill number. If you don't take bill number, then there is no relationship. Yes. Understood? So redundancy is reduced to the maximum, but redundancy cannot be completely what, sir? Eliminated. Okay? Then. So earlier, for all the 20 items, bill number, date, code, name, address is repeated. Now after dividing the table into two tables, a customer purchases 20 items. For all the 20 items, what is repeated is only bill number is repeated. Okay? Then okay. So this is normalization. Okay now? So step by step reducing what's that? Redundancy. Okay. Now still there is a redundancy. Still there is a redundancy. Yes. What that is? Don't consider bill number. Forget about this bill number. Because we need bill number. If you don't take bill number, there is no relationship. Then this is not considered as redundancy. Okay? Apart from bill number, any redundancy is there. Sir, here, sir, see, 100 customers purchased item 1. Possible or not? 100 customers purchased item 1. When item 1, what is the name of the item? A. What is the rate of the item? 100. Sir, here, when item code 1 is repeated, name and rate is repeated or not? Sir, wherever item 1 is there, the name and rate is repeated or not? Yes. This is called redundancy. So in this table, when item code is repeated, name and rate is repeated. So what this is called? Redundancy. To reduce this redundancy, apply second normal form. Apply what? Second normal form. So after applying first normal form, you'll get some output now. If there is a redundancy, then apply second normal form. Okay. Now, then, so what is the second normal form? So what is the second normal form? A table said to be in second normal form. A table said to be in second normal form. 1. If it is in first normal form. If it is in first normal form, that means what is the meaning? First, before applying second normal form, compulsory table must be in first normal form. If it is not in first normal form, you cannot directly apply second normal form. First apply first normal form, then apply second normal form. Then, so a table is said to be in first normal form. Next one, if there are no partial dependencies in it, partial dependencies.
ఇది కథ తెలుసు ఓన్‌గా రాసిన దానికి ఇదొచ్చి తునే పడమంటారు. సప్లిమెంటరీ లాగుంటది. అది కథ తెలుసు. ఈ 2 కథ చేశారు.
Okay, then.
మన ఓన్ కథ రాయాలి.
So a table is said to be in first order if there are no partial dependencies in it.
ఈ మక్కకు చేసింది రాసిన దానికి 4:30
Okay, then.
అవుతుంది.
No partial dependencies in it. Then. But what is partial dependencies? Okay, so that's all. Only three rules you have to remember. First one, what is not allowed. Second one, what is not allowed. Third one, what is not allowed. That is important. That's all. First one, what is not allowed. Multi-valued. Multi-valued attributes are not allowed. Second normal form, what is not allowed. Partial dependencies are not allowed. But what is partial dependency? Okay, na? What is partial dependency? Then let's see. Sir, what the partial dependency is? Suppose then you take table R. In this R, one field is A, one field is B, one field is C, one field is D. Just assume R is a table. A, B, C, D are what? Fields. A is one field, like EMP table, EMP and O, E name, job, salary, they are fields. Like R is a table, A, B, C, D are what? Fields of the table. Then what is A? A is what, sir? Primary key. What is A? A is what? Primary key. A is the primary key. Next one. Okay, na? Then, so the field A is the primary key. Next one. Suppose like A, arrow mark B, comma C, comma D. Then, what the meaning of this is? B, C, D fields. A is primary key. What this B, C, D are called? Non-primary. Non-key. A is key. The remaining are non-key. Non-key field depends on key field. If non-key field depends on key field, then it is called full dependence. Okay, na? In table, non-key field depends on key field, then it is called full dependence. Okay, then. So, then, understood? Like, see, account number balance. Account number balance. How balance is accessed? Account number. That means balance depends on account number. What is account number? Primary key. What is balance is non-key. So non-key field depends on key field. That is called full dependency. Okay. Next, suppose R is a table. A, B, C, D are fields. A is one field. B is one field. C is one field. What is AB is? AB is what? Primary key. Okay. Then what is this is called? Composite primary key. AB combination is primary key. Then it is called composite primary key. Now let's say AB. So C depends on AB. What is this is called? C is non-key. Non-key depends on AB. What is AB? Key. Non-key depends on key. What is this is called? Non-key depends on key. Then what is this is called? Full dependency. Whether it is non-key depends on key. Full na. Here also DC is what? Non-key. And AB is what? Key. Non-key depends on key. That is full dependency. Suppose then, for example, D is there. D. D depends on B. What is D? Non-key. Non-key depends on B. What is B? B is not key. AB is key. B is not key. B is part of the key. What is B? Part of the key. If non-key depends on part of the key, then that is called partial dependence. So that D is not fully dependent on key, it is partially dependent on key. It is not fully dependent on key, it is partially dependent on key. Then what this is called? Partial dependency. Okay, na? Then, so in table, If non-key field depends on key field, then it is called full dependence. In table, if non-key field depends on what part of the key, then it is called partial dependence. Okay, then. Okay, next, see, let's apply this rule on what? Let's apply this rule on the tables which are created after first normal form. How many tables created after first normal form? Two tables. Apply this second normal form on these two tables. This is table 1. Like 1 second. This is table 1. This is table 1. And table 1, this is the then. This is table 1. Sir, here, then, I can say, without checking, you can say this table is according to 2NF. No need to check. This table, you don't need to check whether it is 2NF, satisfying the 2NF or not satisfying the 2NF. You don't need to check. Why? This table is according to 2NF. Without checking, you can say this table is according to 2NF. Why? Because in this table, there is no composite primary key. When there is no composite primary key, there is no question of partial dependencies. When partial dependencies exist, when composite primary key is there, then in this table, there is no composite primary key. Then there is no question of partial dependencies. So this table is according to what? This table is satisfying. This table is according to what, sir? 2NF. No need to check. Okay, na? Then. But you see the table 2. This is table 1 and this is the table 2. This is the table 1 and this is the table 2. Table 2. But table 2 we have to check. Huh? Table 2, we need to check the table 2. Yes. Why? Here composite primary key is there. Because here composite primary key is not there. So simply you can say this table is according to 2NF. But here composite primary key is there. When composite primary key is there, chances are there for partial dependencies. Yes. Then check partial dependencies there or not there. What is the primary key? Bill number and item code. Then, sir, name depends on what? Name. This is item name. Item name depends on item code. It does not depend on bill number. Yes. Then, so item code. Then name depends on item code. Rate. Item rate must then item code only. It's not depends on bill number. Bill to bill item rate changes. Bill to bill item rate changes. No. Yes. Then it does not depend on bill number. It depends on item code. You go to market, supermarket. Then they take item. They read the barcode. If they read the barcode, they will get 2. Name and rate. When they read the barcode, immediately they'll get 2. What that is? Name and rate. Next one. Quantity. Quantity. Item quantity. It depends on item code. If you read item code, will you get the quantity? No. Quantity is what? See, sir, I buy 2 quantities. You buy 3 quantities. Some other customer buys 5 quantities. Yes or no? Customer to customer, quantity is same or changes? Huh? changes. Then that means quantity depends on what? Bill number and item code. Quantity depends on bill number and item code. Quantity 5. Then quantity 5. Suppose quantity 5 is there. Then define that quantity 5. Which customer is purchased that quantity 5? Which item he purchased? Which customer is purchased? Which item he purchased? Then quantity depends on bill number and item code. Then next, comma. Value. Value. Actually, how you get the value? By multiplying what? Rate and quantity. By multiplying quantity and rate, you'll get what? Value. So quantity already depends on bill number and item code. Value also depends on bill number and item code. Sir, see, value depends on quantity and rate, but quantity already depends on bill number and item code. Rate depends on item code. Then value depends on what? Bill number and item code. Yes, then. So what is this dependency is called? This is called full. What is this is called? Partial. Okay, that means this table contains partial dependency. This table is not according to 2NF. It is not satisfying 2NF rule. When it is not satisfying 2NF rule, then decompose, divide the table. Then, so the above table contains what? Partial dependency. So the table is not according to 2NF. Then decompose the table as follows. Then, okay, then. So take this into one table, take this into another table. Take this into one table and take this into what, sir? Another table. Then what? Items table. Items table. What is name? Next one, rate. So take this item code as what? Primary key. Name and rate depends on item code. Name and rate depends on item code. What this is? Non-key. Non-key field depends on key field. Then what is this dependency? Non-key field depends on key field. What is this dependency? Full. And this partial dependency is converted into full dependency. So that is the aim of normalization. Nothing. Normalization is what? According to normalization, table should contain only full dependency. If table contains full dependency, the table is perfect. If table contains any other dependencies, then convert other dependencies into full dependency by dividing the tables. So that is the aim of normalization. Okay, then what is the next one? What is the next one? Bill items. Then what is this is? Bill number. Next, item code. Next, quantity. Next one, value. So what is the primary key? Bill number and item code. Now, so table 2 is divided into how many tables? Two tables. One is table 2, another one table 3. In the beginning, how many tables you are taken? 1. After applying second normal form, how many tables are created? 3 tables. Okay. So what this is called? Normalization. Decomposing the table into number of well-structured tables. So what you are doing? Reducing what, sir? Redundancy. Sir, here, what I said here, in this, if item code is repeated, name and rate is what, sir? Repeated. But here, if item code is repeated, name and rate is repeated or not repeated? Not repeated. So redundancy is reduced or not? Yes. If you repeat item code, name and rate is not repeated. Item name, item rate is stored only one time. Understood? Then. Okay. Next. On these two tables, apply. Okay, na? On these two tables, apply what? 3 and F. Total how many tables? three tables. So this is table one. Table one is as it is. What is the next one? Table two. Next one, table three. On these three tables, apply 3NF. Then, hmm, okay, now then, okay, next. So, what is the 3NF? What is the rule of 3NF? Then, a table said to be in 3NF, one, if it is in 2NF, next, if there are no what trans to dependencies in it. If there are no trans to dependencies in it, a table is said to be in 3NF if it is in 2NF if there are no trans to dependencies in it. Okay. Then, here, what you don't know is trans to dependence. Okay, na? You know two. What are the two? Full, partial. Full means non-key depends on key. Next, partial. Non-key depends on part of the key. What is trans to dependency? Then, trans to dependency. uh, Suppose you take a table or A, B, C, D. A is what? Primary key. A is key. What are the remaining attributes? Non-key. One is key, remaining are non-key fields. Then, suppose then A, B, C. BC depends on BC depends on what? A. Next one. C. Next one. D depends on C. Okay, now BC depends on A. D depends on C. What is this is called? This is called full dependency. And what is D? Non-key. What is C? Non-key. Non-key depends on another non-key. Then it is called trans to dependence. Only three. Non-key depends on key. Non-key depends on part of the key. Non-key depends on non-key. If non-key depends on another non-key, then it is trans to dependency. This is not allowed according to 3NF. Okay. Then, so in table, if non-key field depends on another non-key field, then it is called trans to dependency. Okay. Ah, so let's go to the table one. You apply this on one by one table. Table one, table two, table three. Because how many tables are there? After 2NF, three tables. You have to apply this rule on all the three tables. So first go to table one. Go to table one. Then this is table one. In table one, what is primary key? What is the primary key? Bill number. Next one. Bill date depends on bill date. Bill date depends on bill number. Bill date depends on bill number. Yes. Next one. Customer name and total bill. Total bill also depends on what? Bill number. Next one. Customer what? Name and address depends on customer name. Customer name and address depends on customer code. Then. So customer code. Customer name.